Okay guys, so let's do an example for a wave and a string. I didn't mean to write with this one. Let me do it. I'm going to write this question here, okay? It's a little bit longer. So, a guitar is string of length 40 centimeter and a mass of 1.2 gram, has a frequency of 500 hertz when vibrating in its fundamental mode. Okay, so I'm just going to draw this diagram here quickly before we start looking at the questions. Okay, so this is a string, so I'm going to put some boundary here. Boundary here, it has some length, right? So this part here is what? Length is L over here. And this is in fundamental frequency. This line is not needed. This is, so a guitar of a string of length L equal to at 40 centimeter. Okay? And a mass of 1.2 grams. So we'll make that. So it has a mass. So there is this string like this here, right? It also has a mass of what? 1.2 gram. Okay. Let's write m dash for mass because we are going to be talking about fundamental mode, so we can make a differences here. Okay, just for now we are writing mass as m dash instead of m to distinguish between the fundamental mode m, okay, meaning the mode of the standing waves. Okay, so to differentiate that. Alright, and then it is vibrating at frequency 500 hertz. Okay, and it is vibrating in its fundamental mode, meaning mode m equal to 1. Fundamental mode is this, right? We have one antinode that is equal to, corresponds to fundamental mode. Okay, so please go ahead, write this problem. Just make this diagram in your notebook. Okay, so I'm going to erase this part because I want to write the question, further question, okay? what is the wavelength of the standing wave. So what's the wavelength here, right? So let's write all the given information. That will be helpful for whole other problem, other part of this problem also. Okay. So here we are given what the length is 40 centimeter. Make sure you convert this to meter, 0.4 meter, right? 40 meter. And mass is given, which is, we said we want to say m dash for now to distinguish it from the mode, right? 1.2 gram, which is what? 1.2 times 10 to the power minus 3 kilogram, right? Okay. And then it is associated with mode m equal to 1, and the frequency is 500 hertz. Okay. So now how to find what's the wavelength, right? You guys already know the wavelength for this mode 1 is what? Given by 2 times the length of the string divided by the number of mode. In this case the number of mode is 1, so it's really lambda 1 equal to what? Lambda equal to 2L, right? Divided by m equal to 1. We don't need to write, which is what then? 2 times, what's the length here? 0.40, right? That should give us what? 0.80 meter. That is our wavelength, lambda 1, okay? So this is the wavelength, lambda 1. Alright, so please, make a note of this. Okay, so I'm going to write another question. Makes you should have that information. Question B. B says, what is the speed of the wave on a string? So here we are, you still want to probably write this, all of this down. We are asked what? I'm going to erase this right here, okay? B here, we are asked all the other given information, and then V equal to what, right? Is speed. Okay guys, so I'm going to leave you guys. I'm just saving it because I'll need that information in a few minutes. So just leave that for now. So please try to go through this problem, try to work on this, and try to find what is the speed of the wave on a string. Alright guys, so let us see how far it got here, okay? So what is the speed of the wave on a string? So we know our speed is related to the information we are given. V equal to what? F times lambda. Since this is for, fundamental mode, so it is F1 times what? Lambda 1, right? You guys should have information for lambda 1 from A. F1 is given, so we should be able to find speed straightforward. So what is the frequency? 500 Hz. 500 times lambda 1 is 0.80, so what do we get here? So that, right? Okay, meter per second. Alright, so this is the speed, okay? 400 meter per second. So I'm going to erase this part. I think you guys have enough information now. So I'm going to write here because I will need this information and I don't want to memorize. 400 meter per second. Speed is lambda 1 wavelength at fundamental frequency. Fundamental mode was 0.8 meter. Okay. Okay. So there is another question, number C. Let us see, number C. Oh, this is a good question here. So, what is the tension in the guitar string? What is the tension? So here we are asked all this given information and we are asked what T equal to what. Let us set T as a tension on the string so we don't get confused between the period and the tension, okay? So what is that here? So please give yourself a couple of minutes and try to work on this as well. Okay, so are you guys able to find the tension? So here tension, right? How is tension related to what the information given here? So we know V is speed of a wave and a string is given by what? Equation T is divided by mu, right? And we know mu is what? Mu equal to what? Mass per m dash per L, right? Unit length L, okay? And then we are supposed to find this Ts. So what can we do? We already have information for V from the B, question B. We can find mu because we are given the mass, right? And then we are given the length, so we should be able to find this. So it's really a matter of just doing algebra here. So this equation, let's call equation 1, is square on both sides. That should make us what? V square equal to Ts divided by mu. And then if you do this, then we can write Ts equal to what? Mu times V square, okay? So now I'm going to erase this diagram also here, okay? I need more space here to work on. So Ts is basically mu. Mu is what? Mass per unit length, right? Mass is what? We were given, what is it mass? 1.2 gram, right? So 1.2 times 10 to the power minus 3. Mass per length. Length is what? 40, right? 40 centimeter. So 40 was what we said, 0.4, so that is 0.4 meter, right? That is the mu here in place of mu, and then V square is what? Whatever value you guys got here. So V square. So when you do this, what do you get? Put it in the calculator and see. So it is 480 Newton, right? This is the tension. So, okay, so the tension on this string Ts is 480 Newton.